gender data frame and all that?
I think, let me see, let me open. I think that one data set, can you remember? It's IBM data set. One has IBM, one has customer data. Let me see, I'm going to open this one.
Okay.
Okay, let me see. Yes, no. Let's go to the assignments. Okay, then homework. Week 1 homework, you have a consumer data. Then week 2 homework, you have a IBM data. Can you remember? Did you use the IBM data?
Yes, for IBM. Oh, that's the other question I have for you. When I went into R to try to do the week 2 assignment, it would not let me set the workstation or is it the work? I forgot. Let me
Yes,
see.
working directory.
Yes, it would not let me. It would not let me do it.
Yeah, don't worry that I explained in the beginning. You forget it. I can show you today. When you get stuck over there, you have to change that. Sometimes the forward slash to backslash. Sometimes keep the spaces in between that directory path. Something like that. That kind of adjustment will make your make that work. Yeah, that's why you
Oh,
cannot directory. Yeah, sometimes you have to do some kind of a flight the changes for your path, the way that how you're gonna write it.
okay. Because I did that though. Because I went to because I'm saving everything on my E drive. Because I still was not able to find my other computer, so I'm still using my work computer.
Uh-huh.
So the only thing I'm saving is that one window, with all the where I'm typing up the code and everything.
Yeah, okay, yeah, I can see that you have, okay, I'm gonna pull that out. Okay, that terms.
So yeah, but the week 2, I for some reason I just can't get the setting the directory. So I saved the IBM data on the E drive.
Oh, you have that one in E drive?
Yes. Was I supposed to save it on my computer instead, or?
No, it doesn't matter where you have saved that one. I mean, like when you have that one anywhere, that only thing that from there you're gonna go ahead and then extract that one and send to me. That's all you gotta do. But when you run your data, when you
Mhm.
run the program and that everything has to be in the same platform, same location. Otherwise,
Right.
it was looking for the data otherwise. But on the other hand, once you pull out the data and put it onto the R will, you don't need that path anymore because you have set up that directory to some kind of working directory has been changed to some kind of a directory on the R. So in wherever you are working in R,
Oh.
they get disconnected. Then the data wherever you have saved has to do
Yeah.
nothing with that data now already you work on that one on the R. Yeah, then that means that you have saved your data set some another computer, but now
Hmm.
you have already get everything onto your working directory and then keep everything in the all the data as well as all the directory and everything has set up on or where you
Hmm.
are working in a different computer. Then you don't have to worry about the where you originally saved the data as that because it has to
Okay.
do because you have already imported data into your system. That means our system now.
Okay. Then I think what I'll do then is I will save the
Sometimes it
IBM
might be
data.
looking for, sometimes it might be looking for the where the
Mhm.
location is at, even though you are trying to pull out the data. Let's say that you save in something and all of a sudden you pull out the get the flash drive. You're gonna take out the flash drive and then try to thinking that your data is already that in the R, but the thing is that R gonna go and read from that directory where your the data is at. In that way, you have to keep the flash drive always plug in into the computer.
Oh, so if I don't have it plugged in, then it's not going to recognize the
It's
data.
not gonna recognize where the data. He might gonna be confused and then looking for the data and then looking for the data. Then he cannot find it. Then you're gonna come up with an error message.
Okay,
But
I
it
see.
seems like you have imported data. Imported data is not sometimes, yeah, sometimes it works, sometimes it doesn't. But most of the time it is looking for because the directory means that you give a directory for the place where you have saved your data set. We are
Okay.
not doing anything new, which
Okay.
yeah, like that. Okay, let's see that what you have over here. Okay, then number 15. Okay, then okay, number one. Do you have any question on this number one? I think
For
I think
assignment.
assignment one. What I'm gonna do. I'm gonna go ahead and share with you that you can see.
Okay.
Since I'm gonna share this one with you, I'm not gonna, even though that this is recorded, I'm not gonna share this recorded video with other student. Okay, don't worry about that. Okay.
Okay. All right. I appreciate that.
No, it's against the rules. You cannot
Okay.
do that. I'm recording that one for that my convenience. For if I need something, I can go and looking into that one by any chance.
Right.
Yeah, don't worry. Even though that I say that today's session will be shared with other people. No, I'm not gonna do that one. And then plus that if somebody gonna get into the system, I'm gonna just take it off. Okay, don't worry.
Okay.
Your privacy is that high priority. Don't worry.
Okay. Thank you.
Yeah, it has to be like that. Okay, look at the. Okay, now you can see. Okay.
Yes.
So okay, when you run this one, did you have any problem over here? First
No.
one, no. Then you set up this one. You see, when you set this up,
yes.
Okay, then you read data. So you keep in the flash drive. You normally give the name for that your data folder, and go inside the folder. This is the name of the folder. See, it's in the E drive. See, it's in E drive, and April
Yeah.
blah, blah. It's your maybe flash drive or something like. Then consumer data, you get it, you install the package, you load it, and everything's good. Then display the data frame, my data. You're gonna call that on my data now. That works.
Yes.
Then how many cases were sampled in the data frame? How many cases were sampled?
71.
Is that 71? Huh?
Yeah. Was it more than 71?
When you're gonna go ahead and how do you know that data frame has how many cases? How do you find it?
I think I ran the my data, and then there was 71.
No. My data doesn't show that the whole data set. You know that one. That's why you have to run different things, because it's gonna show the proportion of the data only.
Okay, what did I do then?
No. Don't worry. There's another command or the function to show that how many cases in that one. That's the one that you are supposed to put it over there. I'll show you what.
Oh.
Can you remember what is that? A string. String. Can you remember string? When you have a string.
Oh, so str, and then in the parentheses is supposed to put my data.
Exactly. See.
Okay.
When you run, this is okay. This is what I did. That one. Then go this one. Okay. Number one. Do not display frame. Just see content. Display the content of the data frame. See. Display the contents of the data frame. Look at. Oh, sorry. I think this is something.
Okay, I see. The string str.
Yeah. Then you say that do not say display the contents of the data frame. No, it's not right. This is you have to put str. See.
Okay.
str my data. See.
Okay.
On this side for you to see. See str.
Okay.
Str. Then you can see once you run that one. Let's say for instance, what I'm gonna do. Thomas, I can open. I'm gonna go ahead and open this one. Okay, it's an answer for homework one. Okay, that one I'm gonna open. See. Okay. Okay, there are several ways of getting this one. Mosaic. See, look at. You should. You should. But as I mentioned, you are not. It's gonna appear here. Okay, look at when I'm gonna run this one. Okay, I'll show you.
Okay.
You got what you know what I'm talking about. Yeah.
Yes, I do.
Yeah. Okay. Let's. I'm gonna go ahead and. Okay. Let's see. Run this one. See, it's good. My data location. Okay. I changed. Set up that one. This is on my one I'm doing right now. Because, okay. Then I'm gonna import the data. Good. And now see if you wanna see head and tail, you can run.
Yes.
See how. Okay. And then you install that library. Go ahead and get the Mosaic library. You're gonna just load all that functions.
Okay.
package. See, now all the functions are here. Okay,
Mm-hmm.
good. Okay, then see string my data str. See, it's gonna appear here, but what I did was I copy and then pasted here for you to see clearly.
Okay.
But you don't have to do that one. You don't have to
Okay.
do that one. You don't have to, because on
Okay.
your one, the, oh my god, 1,000 millions here. Yes, yes, your name. Yeah, there you go. See,
Okay.
see, see,
Okay.
see. So when you put like this, that's enough. Then you can say how many. See, this is the number of observation, 2,000.
Oh, it's 2,000.
Yeah. Variable should be 13. That's right. You are right, because it's not be 14, because they're going to count even the first number that even that number that
Right.
has been given for that all the individuals being given as a
Mm-hmm.
variable. No, 13. That's right. This one should be 2,000.
2,000.
Yeah,
Okay.
should be 2,000. See, 2,000.
Okay.
Like that.
Okay.
Then display the top and the bottom of the data. Very good. Head, tail. Okay, you did that one. That's good. Okay, that's good. Okay, then Q1 head and tail. Okay, then another way of getting this one. I'll show you another way of getting this one. That how many
Mm-hmm.
you can put the string too. But if you run this one, see, I'm talking about here. Okay, here. Okay, rather than reading from that one, you can go and say number of rows. See, number of rows.
Oh,
2,000.
also N row. Okay.
In row. Okay, number of rows. Okay, you
Okay.
can use that one too. First one for sure you have to run that
The
function.
string. Okay.
Okay, the second one that you can read that 2,000 from this one. Oh, there's another option that I can just straight go to n row. It will give you that one. Okay.
Okay.
Yeah, and then I think I am pretty sure that n call should work here. Interesting. See 14. See number of columns n call. Okay, but
Oh,
it's not.
okay.
14, it's not a 14, it should be that variable wise it should be 13, because they are they are
The
individuals.
extra.
Yeah. So how many variables in the data frame? Good. Then this one. Okay. 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 Number five. Number five. What's number five? Which variables are quantitative? Where this glimpse? What is the glimpse?
I don't know where I pulled that one from. I think
Okay, you're gonna glimpse something. Okay, let me see where the glimpse is there. Okay, answers. Is that the one that we were running? Oh my god, 1,000 millions. Okay, glimpse. You are trying to put something called glimpse. Okay, what you are trying to glimpse at this stage. Did he work glimpse?
I thought it did because I know
What
I
did
read.
you get? What did you get when you ran in that one, the glimpse?
Let me see.
Can you remember?
No, I don't. I got so much on here. Let me see.
We were just simply asking about that, which variables are quantitative, which variables are qualitative, just okay. There's
Oh, so okay, when I did a glimpse my data,
uh-huh.
it gave me all the data that you gave before. It says like rows 2,000, columns 14, and then the ID household kids vehicles, they have the $sign, and then it gave all the
Or like
variables.
you're talking about like this?
Yeah, just like that. Yeah.
Instead of a string that you use the glimpse, I think.
Glimpse. Yeah, that's what it was.
Okay.
You know what I did was because when I was trying to do all the homework and everything, like I got all mixed up. So I started Googling
Okay.
instead of going back into the chapter. I should have gone back into the chapter because, it tells you which code I'm supposed to use.
What supposed to use? That's okay. Okay. Then we use that one over there already. I read that back over there. Okay. Then we went to. Okay, that's glimpse. Okay. Then I can go. Yeah, here. Okay, glimpse. Okay, that which variables are quantitative? Household, kids, variable, price, expected income. Okay. What is this? Is my data?
No, I think it's LS list.
Oh,
Is it
list.
list?
Okay, list.
Yeah.
Okay.
Yeah.
Okay. That's good. Okay. And which variable are categorical? Okay. Okay. Create a frequency table for state employment sector. See, table for the state and employment sector variables.
Did I
Okay.
forget one of them?
Tally. Okay. Then tally.
Mm-hmm.
You go to data, you go to region. No. Yeah, my data region. Okay. Go to region. You get that one. Okay. Then employment sector, tally. This one. Employment
Mm-hmm.
sector data. Good. Create a new variable with the categories. Yeah, entile. Where's the entile? New variable.
Okay. That's where I guess I did not know what to do on that question.
Okay, then we go ahead and then you're gonna get number. Which number was that? Create a new
Number
variable
7?
for the categories of the household variable as a factor. As assign levels and label to its values. Decide
Mm-hmm.
the labels and labels according to what you believe to be interpretable and meaningful for analysis. There's no right or wrong answer. Just provide your rationale. Okay. So then you go to my data, you go to my household, but they say that when you go to the household variable, as a convert that one as a, like a factor.
Mm.
Convert that to a factor.
So that was supposed to be an entile then on that one?
Create a that's a number 7. No, okay.
Yeah.
Then you're gonna use what you're gonna do. You're gonna divide the whole data set into categories. How do you divide that into categories? By 3 categories. Let's say that for instance, okay, like this. Okay, let me show. Using that function called entile. Okay,
Mm-hmm.
entile. Okay, so this was I'm gonna get that now. See, this is my data. You go to the household to group, to group, or if you want you can say 3 groups. See, household being divided into 3 groups. This is a new name of the variable, and it is going to put back into the my data again. This is the
Okay.
function entile.
Oh, the entile.
Entile.
Okay.
You go to my data, your household, you're going to say divide this into 3 groups. See? 3 groups. Okay. Not only that, once you divide that one, they might gonna give you the new. That means that whatever that numbers that you have for that, let's say that household. Look at the household numbers. See, look at the numbers.
Mm-hmm.
See, you have
Yes.
666, blah blah blah. Like how many people in the household? 6 people, 2 people, 3 people, 7 people, like that. They say don't
Yeah.
go like that. We don't wanna look at that way. We wanna see whether it's a small family, medium level family, or large family, like that. That's
Okay.
why categorize. That's why they want to categorize this one into 3 groups. Whichever that you feel like the more label it in a way that you believe that to be interpretable and meaningful
Okay.
for analysis. Then in that you can say that small, medium, and large families. But once you do this entile, what's going to happen by the group automatically by default, the machine or that program's going to go and assign numbers for them. 1, 2, 3. It is not like a number like the count, how many people in the group. It's like they're gonna think 1 is for the small group, small family.
Okay.
2 for the
Okay.
medium family. 3 for the. They're gonna give you that some numbers which are categorical meaning it has. Then we're gonna say we don't like that one. We wanna give the names. How do you give the names? Look at this is how we're gonna give the name. See.
Okay.
Copy, and then I had to put another line. Okay, share. See, this is this one household. No, what is this one?
Oh, I see. You
See,
assign small, medium, and large is 1, 2, and 3.
yeah, see my data, go to my data.
Mm-hmm.
From the my data, again, you're going to go to household tree group. That's how we call that one. You're going to put it back to that same thing again. See,
Okay.
you're going to get over here my data household, not to
Mm-hmm.
three group. And levels, whatever the levels you had by default is 1, 2, 3. I say no, I need the small, large, and create a factor. See,
Okay.
that's how you're going to create factor. Then you're going to run that head and tail of this one and see that how it works instead of having that. I mean, like you have already have a household, this variable too. In
Mm-hmm.
addition to this variable, another variable called the household 3 group. Household 3 group will be added to your data set, and then in that particular variable, in that column, you're not going to see the numbers, you're going to see small, medium, large. Then you may be thinking, how come it's going to figure out that one? It's going to figure out if you go ahead and look at into that one of the videos that we did in the beginning, you can easily see how that can be done. Okay.
Okay.
Yeah. So if you want, I can show you how that one comes, like give you like a rough idea. Okay, I will show you what's going on. Okay, this is what's gonna happen. When you have the data set, data set, be thinking we're gonna arrange the data set from the smallest to the largest. Okay.
Okay.
Smallest to the largest, or you're gonna arrange that one in ascending or descending order. Okay. Okay. See, I'm gonna share this one. Okay, see, it takes a while for this to start. Come on. Okay, what is this? Okay, let me see. Yeah, then this is what I'm talking about. Let's say that particular data set. Let's say that your data set, those numbers, whatever the numbers you have how many numbers? 2000 numbers. No, what is the smallest? What's the minimum value? Minimum value of this one. What's the minimum value of this one?
It'd be like 1, wouldn't it? Or I see 2 only right now.
No, from this one, household. What is the minimum number of in the household? Let me see. 27. This one. Okay. So this is hidden tally. Okay. See. So let's say the min of let's say min of my data within that one. Let's go to household. See, 2. Minimum is. So let's go to max. So max would be how much? Okay. Oops, sorry. So this one. Max. Let's say the max would be how much? Max is 10. See, some 10. So what we do that for each of all these, okay, we're gonna start in from 2, okay.
Yes.
2 has occurred so many times, okay. So 2 has occurred so many times. This is a 10. How many data points from here to here? 2000 data points, okay. Data. So that means 2 has occurred, let's say 10 times. The next number 3 times have occurred 5 times, like that. Okay, some families, there are 10 families with the household number 2, with the family members 2. There are some families, there may be certain number of families with a certain number of that number, the family members 3, blah blah, like that, all the way up to 10. Okay, so this that all the data point. We're gonna arrange that one. What we're gonna do? They're gonna divide this into 3 parts. Okay, 3 parts. 3 parts. Look at these are called the quartiles. See, these are called the these are called the quantiles. This is the quantile. It's a quantile
Okay.
1. This is a quantile 2. See,
Mm-hmm.
this is a quantile 3. See.
Okay.
So since this is gonna be divided into 3 parts, we're gonna call this one actually terciles. Terciles. Those are terciles. If you divide this into like a 4 parts, we're gonna call the quartiles. If you divide the whole data set into 100 parts, we're gonna call the percentiles. Okay.
Okay. Okay.
That's the percentiles. Okay. So this is T1. I'm gonna denote by T2, T3.
Okay.
So then we need their threshold value. This value will determine whether that particular, what is this value would be. See, the threshold.
Mm-hmm.
How to find the threshold value? See, in order to find the threshold, they're gonna say that the distance, the depth, or we can say the depth or distance of T1.
Mm-hmm.
1/3 times 2000. See.
Okay.
Okay, then 1/3 times 2000, what they're gonna do, then 1/3 times 2000, let's say that, okay, I'm gonna divide this. N means like a number of, see, this is N, okay, sample size. That's a sample size. Okay, we have 2000, I'm gonna divide by 3. Then you get 666.66. See, the decimal, I'm gonna round this to the next whole number. 667th data value. Therefore, T1 is nothing but 667th data value.
Okay, then you add another 667, and that would be quantile or number 2.
Now that's going to be the second tercile, and the third tercile, and keep going like a. See, you need only 2 on this one, only 2/3. Okay, next one only 2/3. Okay.
Yes.
But
okay.
we have a 3 terciles, but I'm looking for the boundaries. Actually, here the right word is the bound of T1,
Okay.
and I'm gonna put that T1 and T2. See, if you put like that, that's the right word. They will decide that if whatever that you have, that anything, this cutoff value decide anything. Gonna be that anything within that region is numbered by that by default by 1, this by 2, this by 3. Then we change that one to small, medium, and large. See.
Okay.
So here, this is the value that decide that whatever the number you have over there, whether it's gonna go to the tercile 1 or tercile 2, being decided by this value.
Okay.
Let's say you have like a 9, okay, 9 family with the family members 9. We don't know whether it's gonna go here or here. We don't know, because there are so many 9s can be in this region. See, in this bound. See, around the bound there might be so many 9 values. We don't know yet, because if you wanna do this one for like a small data set, we can look into. But in a large data set, we don't know, because sometimes the 1 9 might gonna be 1 9. You can think like consider this still as a medium. Another 9 still consider as a large. Okay.
Okay.
It's not, there's no any particular carve of the, it's not based on how many. Okay, it's based on the location. That's why you have to be careful. It's not like, okay, when you have a nine people in the this particular, I'm telling that one for instance. Okay, it's not necessarily be 9. Let's say the 9 number, maybe there are 5 9 numbers gonna be here, spread out over here. This gonna be, look at this point, gonna be 667th location. Okay. Then the next location gonna be another 667. You added to that one is how much? 6. It's nothing but that divided by this one by multiplied by 2. See. Then whatever you have, 2 times 2000 divided by 3 would give you 1333. See. See? Next, this number would be this cutoff value 1334. See, 34. See. So which data point? There might be 9, which there might be some 9s gonna be 100, 1300, 30th one gonna be 9, 32nd, 34, 33, 34, 35, 36. See?
Mm-hmm.
Then 1334th one is the cut value. See, that's a threshold value. Any
Okay.
value 9, there are some 9s gonna be below that one. See, some 9 gonna be above that one. You see? See this 9. See these 9. The way that we have counted that this is 9 gonna be 130th data value. The
Okay.
next 31st value. 131st value, even though it's 9, you don't call that one small, large family. So still you call the medium because the way that it's been divided. Then you got next value like that. But the threshold is 1334th one. But you have another 1335th one. Look at the 35th one, gonna go to the medium, the large one.
Okay.
It's gonna be large data set. That means that family, even though that 9, it looks like sometimes it's gonna appear like a medium, sometimes appear like a large. See, so does with this other threshold value too. Sometimes certain value with the certain value, like a 2 people, 3 people, 4 people, like let's take like a smaller number. For the bit small and medium, they will have the same issue.
Okay.
We have the same issue like that. Let's say that, for instance, that if you have let's say that you have, I'm gonna say that 1, you have a 2, 2, 3, 3, 3, 3, 4, 4, 5, 5, something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, your n is 11. Let's say n is 11. Okay, I'm gonna go ahead and find that T1. In order to find the T1, you're gonna go to 1/3 the boundary between T1 and T2. Okay, boundary between T1 and T2. See, the first number is 1, last number is 5. I didn't write the rest of this. Is the data set. Okay, so the first, okay, I'm looking for this one and this one. I'm looking for this guy and this guy. So T1, this is T1, this is T2, this is T3. Tercile 1, tercile 2, tercile 3, 3 region. I'm looking for the bound, this bound. How do you get 1/3 times 11? Let's say 1/3 times 11. Okay, 11 divided by 3, 3.6, 3.6, approximately 4th one. So I'm going to go to the 4th data entry. Okay, 1, 2, 3, 4. See, that's the bound. This is the bound. Okay, this is the bound.
Okay.
Okay, look at the bound. That's the bound. So it's going to be, if it is in the, that's the bound. If you get another, I'm going to put this on another 3 for you to see clearly. See, okay, another 2. See, look at that. 4th one is my bound. Okay, then I'm going to go there. Then T2 and T3 bound. 2/3 times 111 times 11. So 2 times 11 divided by 3. 2 times 3 divided by 11. 2 times 11 divided by 3. 7.3, which is 8. Then I'm going to go to 8th one. See, first one, second one, third one, fourth one, fifth one, sixth one, seventh one, 8th one. See, 8. 8 is 4. See, that's the next bound is this one. See, 4. 4 is the next bound. So think about this 3. This 3. I'm rounding this one. Would that be small or large? Small. No.
Yes.
That's a small family, because I'm going to tell that one, anything below that 3, this 3 is small. Anything in between that 1, that 3, and 4
is medium.
Medium. Okay.
Okay.
Medium, large. But look at this 3. I'm going to go ahead and look at this 3. This 3 is not considered as like a large, small, medium. But if you get a 3 here, medium. See, the size is the same. But you're going to call that on different family sizes based on that where this going to be located at.
Okay.
That's why you see, it's gonna be here. See, the first three here. See,
Okay.
another three here, another three here. But this three, if you go to this three, you're gonna call the medium. But if you go to this three, you're gonna call what? Large.
Large. Okay.
Oh, sorry, small.
No, small, that one. Yes.
This is a cutoff value gonna be the fourth entry. 1, 2, 3, fourth entry. This is the threshold value, and the next threshold value would be by the 4.
And that would be the large one.
That would be the large one. But if you pick sometime look at this way, like okay, I'm gonna put another 3 here, another 3 here. Look at what happened now. This 3 is large. This 3 is small, medium. 3 is what?
That one's a small one.
Small one. Yeah, it depends on not the value. It depends on the completely the location. Okay, that's what I want to explain. But it's been done by this. When you run that one, it will take care of everything, and then you don't have to be that kind of like the flabbergasted, stun and shock, and later on see how come that the same number being going to be in 2 different groups, sometimes small, because of this reason, because of this particular reason. I just explained to you with like a small data set. You saw that what exactly happened. That even though there's value wise, they're gonna spread out like this. See, first entry, second entry, third entry, fourth entry. I'm talking about the person. Okay.
Okay.
First family, second family. The way that how we collected data. See, because of that, you cannot condense all these 3 together and say, oh, there's a 3 would be one number. No. It has to be spread out. Because you cannot say 3 would be one number. Why are we going to spread out like that? Because those are different individuals, different information. See? First individual, second individual, third individual, fourth individual. See? Third individual definitely has a small family. The fifth individual definitely has a medium family.
Medium, right.
Then if you go to over here, ninth individual has a large family based on the way that it has been. But what I'm trying to tell you that if you see that kind of a discrepancy, that something like that, if you don't feel like it is a discrepancy, it is the way how it's been set up by the tile. Okay.
Okay.
So same number gonna appear in the small group, medium group, or large group based on the how many data points are over there. Okay.
Okay.
So you got that one. Okay, that's good. Okay. Then let me see what's the next one. Next one would be yes, sure. Okay, I'm gonna go back to your one. Okay. Yeah, we did that one. See, that's your one. See, I put it on your one. See.
Okay.
So then, see, this is your one. Yeah. See, then we check the min max as well. Then filter observation that have missing data. See, filter. Go to my data age. Now, see, you call that one my data
2.
The filter data.
I filtered the so no NAs.
Okay. You call that one my filter data. Okay, you call the my data. Sorry, my data.
Yeah.
Then you go and for how many later on what they were asking about. Later on, ask that filter observation of missing data on the variable in new data frame. New data frame. Okay. What is this one? You look for the age and see that whether they were properly that filtered or not. Okay, good.
Yes.
Yeah, filtered data. When you anytime when you do like this, you can rather than going to that all the data, you can go to the head or tail. Okay, like that. Number 9. How many observations were dropped? How many dropped? How many dropped? How could you know how many dropped? 844.
Now I don't even know if that's the right answer now.
Yeah, how many? That means like in the beginning, how many data entries you have?
There was 2,000.
But how many missing actually?
When I forgot what I did, but it said there were 844 omitted. That's what did I do?
In which one? You're talking about in the age, no?
Yes.
Okay, you can easily find that one by going to stream. Go to stream. Go to stream of new data set. See my data 2.
Okay.
See my data 2. If you run that one, what do you think? You can see that how many gonna be in that one.
Mm-hmm. Oh, I see. And then you subtract that from the 2000 then, right?
Yeah, exactly. That will give
Okay.
you that how many be missing.
Okay.
They ask that how many observations were dropped, no, based on the missing values in the age variable.
Yes.
Yeah. So that means like that those are the missing values, are the drop ones, no? Am I right?
Mm-hmm. Yes.
Yeah. So you go to this one, okay, you go to this one and get the value and
Mm-hmm.
and then subtract from that. In another way, this is from this one you can find. That means I'm gonna write this one in another way. In row, okay, number of rows
Oh,
in which one? Original data set, my data,
okay.
minus, huh? Okay. Deleted everything. Whatever. String my data 2. Okay, then that's a one way to get that one, and then you can check, then subtract. Then you're gonna go ahead and run the string for 2000. You don't need to run that one and take
Mm-hmm.
the difference between the number of observations. That's a one way. Another
Mm-hmm.
way, you go to number of rows in my data. Number of row in my data. Okay, minus number of row in my data 2.
Oh, okay.
That would give you the answer. The way to find it. That one. See.
Okay. So when you run that, it'll just subtract it for you.
So you're gonna subtract. Yeah, it's gonna subtract for us. Yeah, that's right.
Okay. Okay.
See.
Okay.
Then you did the create a histogram for the filtered data. See, you go to my data 2 and then see age
Mm-hmm.
data. Very good that you did that one. Create
Mm-hmm.
a histogram for the create a histogram for that one. Now draw a random sample of 10 observation from the filtered data frame in the new data frame. See.
Mm-hmm.
How do you get the sample? So you're gonna do that one with replacement or without replacement? Are you getting with replacement or without replacement? Yeah.
Is that on number 10?
Yeah, number 11. Draw a random sample of 10 observations from your filtered data frame. You're gonna get some sample with the 10.
Oh, that's coming from the one that's all the NAs are gone, right? So
yeah, from that resample, you're gonna get a
yeah.
sample of size 10 from the
Right.
filtered data. Then you have
Okay.
to use, then when you're gonna pick that data,
Mm-hmm.
okay, sample and then my data to 10. If you run, did you get the answer for that one? Or you have to just do that one in different way? With or without replacement? See, there are two ways you can get this done, okay?
Okay.
Over here for you to see. Okay, I'm gonna see answers for homework 1. Do filter data 1 and do this one, resampling. See, resample. See, if you use a sample,
Mm-hmm.
look at, you can see that if you use the sample, you have to use this one, see, without replacement.
Okay, I don't understand. What does the without replacement mean?
Yeah, I'll show you. I will show you what that means.
Okay.
Okay. Let's go to. I'm gonna get here something. Let's go to Canvas. Let's see in the beginning. Flip. Flip. Okay, this one flip. Boolean. Compare. For humans. Compare. Saving R in objects. Sampling from population. Sampling from population. Sample, see. Sample this one. Okay, that's see. This one, if you do with the sample, it's called that with replacement. Okay. The other one without replacement. Okay, I can show you exactly the place where. Where they start this one. Okay, that's okay. I can explain like this way too. Okay, so this is, let's say that without replacement means like that. Let's say that if you have like a certain value, certain data, certain numbers. Let's say that okay. Roll in a die. Okay, roll in a die. You have 1, 2, 3, 4, 5, and 6 only. Okay, you're gonna pick a sample of this one. Okay, this is the population. You have these numbers. You pick a sample. Okay, when you pick a sample, okay, if you pick if you do this one, let's say you need a sample of size 10, okay, sample of size 10, okay, I'm gonna say size 10. Okay, not this example. Okay, I'm talking about different example. You have only 6 numbers. When you're gonna take this one, okay, if you do like this way, sample, okay, sample, okay, and then you're gonna go to your data set. Okay, just say my data, name of the data. Okay, data, comma, then put you 10. Okay, and then you're gonna save this one to something called, you can say random sample or something, random sample. You can
okay.
You can say RS, random sample or something. But the thing is, this won't work. The problem is that when you put the sample, every time sample means without replacement. This means without replacement. That means whatever the number that you pick, let's say that you by accident you pick 1, you're not going to put it back. Now you are short of the number. See, there's no 1 anymore over there. One you pick from the population for you to pick for the second one. Second, there's no chance for 1 to be selected. It's gone.
Okay.
Okay, you say, let's say next one is 3, you pick. Now 3 is gone. If we do randomly. Next one you pick 6. 6 gone. There's no way you can pick a 6 anymore. Then you keep going. After 6, okay, then this gone, then this good. Next one, let's say 2 gone. Next one you pick 5, then 5 gone, and last one is 4 gone. And but still you are only 6 numbers in the sample. You need the 10 numbers. How could you gonna get 10 numbers? That's why this won't work in that scenario. That means without replacement. You're not gonna put it back. Instead of that, what I'm gonna do, I'm gonna put it back again, whatever I got. See, same thing, 1, 2, 3, 4, 5, 6 numbers, population in that roll in a die. You're gonna put with replacement. See, with replacement means like whatever the number you pick, let's say I pick 1, I'm gonna put it back to here. In that way,
Okay.
you're not short of the number. And you keep picking. Next one would be 1 again. Next one would be 1 again. The next one, let's say 6. And you can keep going and then get whatever the numbers you want. By right, if you do that like that, you use the code resample data, comma this one, and then you're gonna do this one. Do how many times? 10 times. Or you can go to resample and data and straight go to 10. That would work. This one works. This one works. This one in that scenario doesn't work.
That one doesn't because there's nothing to put back in.
Out back in, it's okay. So,
Okay.
but in our case, the way that you have done here, that's the safe way of going that one. But since you have used that, even that the sample, I prefer that if you use this, if you prefer this one, see, random sample in that way, see, without replacement, see, without replacement.
Okay.
Okay. So without replacement, sorry. It's not without it. This with replacement. No, with replacement. This is not without. With replacement. With.
The other one is without because it doesn't say resample on it.
Resample on it. Yeah. Resample means that replaced. Yeah. Okay. Then I'm gonna go to your one and then. You can say Sam. This one, if you want, you can say Sampon. The other, see, Sampon resample. You call the my data too. See, my data. Data. To with replacement. With replacement, then you can run that one and see. Okay, we can take the O. Or you can say sample, some sample. Okay, this one. Sample. To do this one 10 times, you go to my data. Do and then do 10 times. You can do like that.
Okay.
This one okay too. This one okay too, because they hear that you are not short of that one because the 2000 data points. Okay, you're not gonna run because the 2000 data points you have enough for you to without or with replacement doesn't matter. This one I'm gonna put over here without
because there's no the resample. There's just a sample.
Yeah, there's just a sample doesn't matter. You're not going to go short of that one. But every time you pick one, you don't have to put it back because it's a huge pool, like a 2000 points. You are not running out of the other numbers in the population for you to pick like a 10 numbers. You can easily pick 10 numbers from the 2000.
2000. Okay.
With or without replacement. So with replacement like this, without replacement either this way or this way. But in like a roll in a die, and then if you are looking for 10 numbers, okay, sample of 10, you have to
do replacement.
Yeah, perfect. Very good.
Okay.
So you got that one number. Is that number 11? No, number 11.
11.
Okay, yep. Go to 12. Create a histogram of the age variable from that particular random sample. See, you did that one. See. Once you get that one, you can just see random sample. Histogram, okay. Data is sample, okay, good. What do you notice is different between the random sample and the data set histogram? Respond with the code and show. What is they not they isn't represent the populations in doesn't show every age group. See, or yeah, that's right. They don't look the same. No, they don't look the same.
Right. They look different.
They're different.
Mm-hmm.
Now they say they create a new variable. See, create a new variable. Create a new variable of the income variable called income3 with 3 labels and assign level with the labels to. See?
I didn't know that one. Yep. I didn't know how to do that one.
Yeah, that's the one we did the same way. Can you remember earlier? Entile, that's the same thing.
Oh, okay.
That's the same thing. That's the same thing. Okay.
Okay.
That means, see, look at it. You can call that one filter data or new data or whatever they say, filter data, income3. I'm going to go to the filter data, but your one, you don't have a filter data. Your filter data has a name, my data 2.
Right.
So I'm going to change this one to my
my data too.
My data, data 2. But
Mm-hmm.
the name of the new variable called the income3. See,
Okay.
call that one income3. See, call that one income3.
Mm-hmm.
So you're going to go to entile and you go to my data. Within my data 2, you have an income. You go to the income and create 3 groups. By default, they're going to give the numbers 1, 2, 3. They were categorical numbers. But you don't like the numbers. You want to give the name, low, average, and high. Something makes sense. So you go back to your my data 2 income3, and here whatever you call this one being changed. Okay, that's why we're gonna get this one back. You go to my data and then do the changes for the income3. Okay.
Okay.
My data 2. See.
Okay.
And it's gonna be like this. Low levels below. And then if you wanna run that one, it's called again my data 2 income3. See, you wanna run and see. Okay, that's number 14. Good. Okay, that's 14. Then 15, use the aggregate function to compute the mean and standard deviation of 3 quantitative variables by one categorical variable. Categorical variable. See? So you're gonna go to aggregate. You're gonna get the household, our kids. Okay. So you're gonna looking into that three one. No, use the aggregate function to compute the mean and standard 3 quantitative variables. You can do that one at the same time by binding. No, you're gonna look into household, hours per week, kids with respect to region. See data, my data function mean perfect. See, perfect. Yeah. See. Yeah,
and that one's a standard deviation on the last one.
Yeah, then the last one you do the same thing with the function. You're gonna do the standard deviation. Okay, then what you did was, you were adding numbers through the column. Okay, through the column. Is that clear? You're gonna go to a particular region, but if you go to the region, but region wise, let's say that there are one region, let's say that Midwest or something. Okay, for my convenience, I'm gonna say like that one. Okay.
Yes.
The Midwest region, you go to household, and then you're gonna measure everything, find their average, average of household column wise or row wise. How do you do that one? This answer, whatever the value you got it, did you get it? See, column wise or row wise?
The regions were on the rows, and then the columns were the household, hours per week, and the kids.
Yeah, but when you got to pick up one region, within that region, you get the household. Let's say you have a household for the particular region. So when you get that means this ever mean for what do you mean? My mean, this mean, what that mean? Mean like, let's say they go to the first entry. Is that for the first entry mean for 3 regions or just 1 region?
I think it's for
you know what I'm talking about. Okay, I'll
Yes.
show you
Isn't
something.
it for the mean for the whole region? So like for the Midwest, for the household, then you're saying it's the mean for all the regions, the region combined, isn't it?
The region combined. Okay, let's see what we're gonna get it. Okay. 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 No, I think the wrong. Okay. 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 This is another way of doing that one. See. Okay. See. Sorry. Here. See. Okay. This is we did a different way, but I'm gonna run this one. Okay. Income. See.
Okay.
Three quantitative variable by one categorical variable. Income three. See, because the income three has been, see, in this case
Yes.
that I did for the income wise. Because the income now income three, in this case, you're gonna check whether that is for the low income. How many hours per week they're gonna do that one for each and every one. Okay, let's run this one and see what you get. Income three. Okay, I didn't run income three. That's the problem. Okay, income three. Okay, here I had to run that one. Then run. Okay, good. Okay, then let's go over here. See, for this has been done for what? All the low income. See,
Okay.
low income. That you go to the low income, and the family is gonna work on average 37.31 hours per week. That's what he says. Average income people, high income people, how could they gonna work?
Oh,
See?
okay.
So that means that when you do that summation, you have all the data column wise. Can you remember? Your hours per week for 2,000 people, hours for the 2,000 people, but column wise you have that one.
Okay.
Okay, but when you have that data, this is what I'm talking about. Okay, I'll show you how to get it clear. Okay, let's see. Then let's say that this case that hours per week. Okay, so the data starting from the first individual to the 2000th individual, you have like that. Okay, then what we're gonna do later on, we got some kind of a category called the income three. Okay, income three. So income three will give you, okay, these people being that now categorized into this way. See, low,
Okay.
medium, low income, medium income, and high income, or something like that. So the average, when you get the average, you're gonna get the average. How do you get the average? This average. That's what I want to. It's gonna stop here. Average for these guys. Average for these guys. See, they don't add all these.
It's just that one low, the low, medium, and high.
Exactly. It's one low, medium, and high. That means anyhow, okay, that if you want that number of the average number of hours per week, average number of hours per week, that's a grand mean. See, Y bar. You can get it that one too. See.
Okay.
I'm not looking for Y bar. I'm looking for Y bar low, Y bar medium. Can you remember that yesterday we were explaining that on Monday? Y bar, Y bar high. See.
Yes.
That value, this value, this value. That's how they got that one. But anyhow, what I'm trying to do that one up to this point, the programs or the machine's gonna come and calculating, adding all these numbers all the way up to here. Stop it and divide by how many gonna be in that category. Okay. And again start from here and then keep going and over there and then add together and then divide by number of people in that medium section. And then go starting from here all the way up to here, add all that number of hours per week for all the individuals in the high income bracket, and then divided by number of people in that bracket. That would give you this value. See, so anyhow, what I'm trying to say that even in this case, or this case, or this case, or this any of these cases, they did all the summation column wise, not row wise. Okay, not row wise. Okay, but in
Column wise.
column wise. Okay, then in your case, let's get back to what you have over here. So when you have over here the way that you have put, we can talk about one at a time. Let's say, yeah. See, you're gonna say household. Okay, household. Okay, household by the region. Okay, household by region. How many regions we have in this data set? What are the regions? Let me see what are the regions. Where are my regions? Oh, see, West, Midwest, Northwest. There are so many, I think, no? How many regions?
There's only like, I think four regions, Midwest, Northeast, South, and West.
Northeast, South, West, and okay, like that. Okay, okay. The way that you have done over here, that let's say that you go to the household. Okay, you're gonna go. That means you created something called the household. Now that's a household. Okay, it's not based on that anything. It may be any variable in the column, the data set. Okay, you go to household. See, household. You have a 2000 data here. See, 1 to 2000. What they did was they divide this into 4 groups. One is north, no? Is that north?
North,
south,
South,
Midwest. What is the other one?
See, Midwest, Northeast, South, and West.
South and West. Okay, let's say this one West, Northeast. Okay, the Northeast. So what they're gonna do? They're gonna add everybody in this one, everybody in this one, everybody in this one, everybody in this one. See, because of that, okay, you can instead of this one. Okay, I'm talking about one at a time. Okay, you have another way to get this done. Okay, I'm gonna see.
Okay.
I'm gonna show you that how you can get that one too.
So what I did, is it wrong or?
No, you're right. Perfectly right. Perfectly.
Okay.
That's perfectly right. But I'm trying to explain you what happened in that one. That's what I was explaining.
Okay, but there's other ways to do the same thing, though.
Same thing, but because I'm going to show you over there another advantage for using that one, because that can be used even not only column wise, row wise as well.
Okay.
Some situation, let's say that you have all the individuals, they have a thumb length. Okay, thumb length. Okay, one like there are 5. Okay,
right.
The fingers, finger length. Okay, the thumb, index finger, ring finger, middle finger, and the pinky, like that, or 5. That I really want to know that each individual's average finger length, rather than the average of the pinkies only. Let's say that I have this thumb length, thumb here. That column you have a thumb. The next column you have what? You have a, let's say that next one thumb, index. Okay.
Okay.
The next one you have the length for that middle. Okay. Next one you have a ring, and then pinky.
Okay.
I'm not interested in find the average of the thumb lengths. I'm interested in find the average of what? Individual's fingers length. Individual fingers, all fingers length. See?
Okay.
That means you are adding this way, row wise. See?
Oh, okay. Okay.
Row wise. Sometimes you're gonna ask that there are several items that okay, give me not the items, that particular items average. I don't need that items. Give me that first persons, that all the items like a GPA. First class, second class, third class, fourth class, fifth class. Okay, 5 classes you are taking. All the 5 classes, if you want to find that they are GPA for that all the classes, you not going to add them that column wise, not the GPA for the first class. That's a different thing. That's a grade point average for the first class. But I'm the other way around, and look at this. This is the best example. I really want to know that each individual's all the finger lengths, average finger lengths, on average. these people have a that how much that their finger length would be. That means you have put all the fingers, their numbers or their values together and then add together and then divided by 5. They go that way, not by the, not like I'm not interested in this guy. I'm not interested in Y bar. I'm not interested in Y bar thumb. I'm not interested in Y bar index. I'm not interested in Y bar middle finger. I'm not interested in Y bar ring finger. I'm not interested in Y bar of pinky.
Okay.
Not those one. Not these. Not those.
Not the columns, just the rows.
Rows. That's why the other method will be very beneficial. That when you're going to use it, you can easily use that one. That's what they were talking about. Okay, I'm gonna use this one.
Okay.
Okay, I'll show you. Okay, I'm gonna say that. Sometimes that you want that the average. Okay. So, see, this is, see, let's say that some kind of a household, kids, vehicle, income, age, hours per week. Okay, I'm going to combine that one and put it to something called VARs. See?
Okay.
Then I'm going to use this function. Look at this function. Apply my data. Okay, my data. Okay. My data, I pick only these ones only. See, that's why they call VARs. See, this is called the VARs. This is the bracket, comma. This is like a matrix. The first one you can do the space and go to the column wise. See, you do the column wise. See, that's why they here column. Margin means you do the column wise here, because in this case we are doing column wise. Can you remember? Can you remember that when I was drawing that one? Show this one. We did the column wise for that. If it is by the region, we did by the region, then it should be column wise. See, then you're gonna do that one. That's the way you can do that one. See, and the standard deviation can be even calculated for these. See, they say the household hours. See, the same thing. And I'm gonna get rid of this one. Vehicles. You didn't pick the vehicles. You put the household. You put the hours per week. Okay, I'm gonna get this one and put it here. Put it here. Hours per week, comma. Then you get the kids. The rest I'm gonna take out. See? That one. See? Then this my data go to this one. You can do that one by my. See, I'm sorry. This one till the region. See, through the region. See.
Oh. Okay.
Region. See, region wise, they're gonna do that one region wise. See.
Okay.
Other way, but let's say that you want to do the same thing. The 2 means like column wise. If you put 1 here, row wise. See. So, but here we are doing column wise. Then I put a 2. Okay.
Okay.
Like that. See, another way of doing that one too. But you did good, very good. Everything's perfect, very good. But some places you can, did you make a note of that, what we were talking about, some places, can you remember?
Yes.
No, yeah. Then I think everything in a good shape, very good shape, yeah. So are you working on your homework too, or what happened to?
Yeah, I'm still, I was having issues, remember, loading it, but what I'm going to do is I'm going to start slowly going through, you know, the assignment too. So do you think maybe possibly on Friday or something? I'm going to try to get it done by Friday.
Yeah, that's good. That's very, very good. I mean, like, plus that did you write that your directory path like the same like over here? If that's the case, you cannot have any issues if you didn't have any issues for this one.
Yeah, I think I did it differently. That's why it didn't load right. So I'm going to try to reload it again.
Reload again with the same way like you did over here, because this here it worked perfect, and in that way that you have to just stick to the same thing. In that way, you're not going to have any issues. If you have
Okay.
any issues, just we can schedule a time, and then I can help, like today, for you to get all these done. Okay.
Okay.
Yeah.
I appreciate it. Thank you.
Any time that this is in a very good shape. Yeah, I think this is good to go, and then I'm gonna grade it and send it back to you like maybe like tomorrow before we
Okay.
have the class like that.
Okay. And then I already so I did finish the chapter 1 and chapter 2, the review questions.
You did that one, no? Okay.
Yeah, and I submitted it through the UCLA, the ebook.
Ebook, yeah, okay. Then I can put I can check that one and then put the grade for that one too. And then 5 and 6, that as I mentioned earlier, that if you are running out of time, that just stick to one of them. Don't try to do that. Can you remember I had this discussion earlier too? From
Okay.
5 there are 2 sets. Again 6 there are 2 sets for your next quiz. So if you feel like that you are don't have that much time, just do one of them. Even from there are 4 sets. You don't have to do 4 of them. Just do one. Either from that one from chapter 5, or one from chapter 6.
Okay.
That's more than enough for me to give the full credit for that one.
Okay. Thank you.
Yeah, you can do like that too. Then so you are working on that this one too, no? The midterm test.
Yes. Now the midterm test, that's the one that is it the salary one? The salary gender data, or is that something different?
So let me see. Midterm. Midterm. Okay, go to assignments. Midterm. ACS data, no? Can you remember?
Oh, okay.
ACS data. This one. See, U.S. citizenship. See.
Okay. Okay. Yeah, I have that one saved too.
Yeah, language, hours, race, income, merit. See, there are only like, see, 1, 2, 3, 5, 6, 7, 8, 9 columns. This is the data set.
Okay.
Yeah, this data set, let me see how many we have on that. Look at 1,000, no? 1,000. See?
Yep. Okay.
1,000 entries like that. So yeah, you can use that one, that data set. I think it's right next to that. It is under that midterm. I think.
Okay.
And make sure the final exam, as I mentioned the other day, final exam gonna be that review questions for chapter 7. Okay.
Yes. Okay.
So in that everything in a good shape. Okay.
Okay.
You have any other questions?
No, I think I got it. Thank you so much for helping me.
Anytime. Okay, I'm gonna let you go. You have a good night and then stay safe and be well. Okay, see you tomorrow. Take care. Okay.
Okay. Thank you. You too.
Thank you.
Okay.
Bye. Bye.
Bye. Bye.